Hello mathematicians, we're now going to have a look at the effects of symmetry in the domain. There are two types of symmetry that we look at in this course, and they are to do with even functions and odd functions. Even functions are those which are symmetrical about the y-axis. In other words, they're unchanged by reflection in the y-axis. So the algebraic test and definition of whether a function is even is whether f of minus x, which we know is the condition for reflection in the y-axis, equals f of x. So if we looked at this parabola here, for example, we can see that it's symmetrical about the y-axis, and we can also see that if we rotated this around the y-axis or reflected half of it in the y-axis, then the image would be unchanged. Odd functions are said to have pointwise symmetry about the origin, which means that if we imagine putting a pin just there, for example, and rotating the shape through 180 degrees, then the shape would look the same. Doing that, of course, is the same as successive reflection, first of all in the x-axis and then in the y-axis. So the first reflection of this part here, I'll just concentrate on the upper part, this part gives you that, and then we rotate in the y-axis and we get to that, because the other half goes exactly the same. Now, the algebraic definition is f of minus x equals minus f of x. So with these two algebraic definitions, we have a test which we can apply to see whether something is odd or even, but most functions are neither odd nor even, so we shouldn't be surprised if something fails that test. Let's have a look at this test in action. Now, most questions will just say either to show or determine whether a function is even, odd, or neither. They won't say this bit, to simplify f of minus x for each function. But that's the process. So we have f of x, we take f of minus x, and we see what happens. So if we take f of minus x, that means, and we need to show all of these steps if we're doing a proof. So we put minus x where x is. That gives us x squared minus 9, and we notice that x squared minus 9 is the same as f of x. So f of minus x does equal f of x, therefore it's an even function. Now we should have known that's what we would get, because we know this is a parabola slid down the axis to cut at 9, and we know that a parabola is, at least one centered on the axis, is a symmetrical function. Next one, f of x is this, f of minus x, the thing that we test. So we put minus x in here and cube it, and minus x in here and square it. This gives us minus x cubed plus 5x squared. Now, minus x cubed plus 5x squared is not the same as this, so it's not an even function. However, it's also not equal to minus f of x. If it was minus x cubed minus 5x squared, then we would have had an odd function. So this is not equal to f of x, and it's not equal to minus f of x. So therefore it's neither even nor odd. Okay, so have a go at these ones in 3C.